A follow-up video from a previous video I made on specific heat capacity for Year 11 physics. So I'm going to be doing some examples to show you how this formula works. So let's suppose we need to work out how much energy is required to heat 100 grams of water from 10 degrees Celsius to 30 degrees Celsius. Okay, first step in solving any problem in physics, write down what we know. Well, we know what, so write down the formula, I should say in this case, which is the specific heat capacity formula. C is just delta, it's just Q over M delta T. What do we know? We know what M is, 100 grams, which we need to convert to kilograms, which is 0.100 kilograms. We know what delta T is. Okay, it's just, so delta T is final temperature, T sub F, minus initial temperature, T sub I. And that's 30 degrees minus 10 degrees Celsius, which is just 20 degrees Celsius. Okay, that's what delta means, final minus initial. Same thing with things like delta, let's say delta V. V for velocity, that's the final velocity minus initial velocity. Okay, that's what delta means, changing from your final state to initial state. So we also know what, so the question doesn't specify, but you can look it up in a table, in a textbook. The specific heat capacity of water is about 4,200 joules per Kelvin, per kilo per degree Celsius. Okay, so we're going to work with degrees Celsius in this case, which is perfectly acceptable. So we need to rearrange the formula in this part here. So Q is just Cm delta T. C, let's plug in C, 4,200 times M, 0.100 times 20. If you do all that, you'll get an answer of 8,400 joules. Okay, so that's how you do it.